Welcome back to linear algebra. Let's jump into Anki to begin with. What do we got? Hold on. Not having that happen. Alright, we got 7 flashcards. Here we go. Here we go. Of what matrix is A to the negative n the inverse? A to the n. What must be true for a triangular matrix to be invertible? All the entries in the main diagonal must be non-zero. What must be true for the product of two symmetric matrices to be symmetric? The product of two symmetric matrices to be symmetric? They commute? Yeah. What is a homogeneous linear system? What is a homogeneous linear equation in the variables x1, x2, ... xn? x1, or a1x1 plus a2x2 plus ... plus an xn equals 0. If a diagonal matrix D has diagonal entries d1, d2, and dn, and if k is a positive integer, what is d to the power k? Basically, it's a diagonal entry with each of those being to the power of k. Each diagonal entry being to the power of k. Must the product of upper triangular matrices be upper triangular? Yes. If A equals A sub ij, surrounded by brackets, is a symmetric matrix, what is the relationship between aij and aji? Well, they're going to be equal. All right, that's it. So I'm going to grade what I did yesterday, and I'll be back to recall how I did in a little bit. All right, so I got all of them right from yesterday except for one, which I did talk about yesterday. I wasn't exactly sure. The codomain should have been R to the 4 here. I was a little confused because the output or the resulting vector had 4 basically entries, but I was like, is it R4? Because one of them's 0. What's that? But anyway, it's R4. Even though it was just a 0. I'm going to continue working on more practice problems now, and then I'll be back in a little bit to recall how I did. Or what I did. All right. So I finished up 22 here, showing that x and the transformation xyz to x plus y plus ex is a matrix transformation by doing the basically homogeneity property today. T to the times the scalar u, or times the scalar times u, scalar k equals the scalar k times the transformation of u. I showed that. Okay. Then after this, find the reflection of ABC about the xy plane. I believe that the standard matrix is that. And then it's just have a negative c. What was the actual question? Now that I think about it, was it it might have been find the standard matrix. 32. Nope. It was that's what it was. Same thing. This one was find the orthogonal projection of ABC onto the xy plane. I believe that's this. So there's that. Okay. This was find transformation of A of the scalar k times standard basis vector 1 based on using inspection. And that's what I found. It was the scalar, or the standard matrix was ABCD, 2 by 2, and then 48. transformation xyz equals xzy, and then using the standard basis vectors to find the standard matrix, pulled this out of a graph. And then finally, I got started on a proof, which is starting off of if the transformation is from Rn to Rm is a matrix transformation, then transformation of 0 equals 0. So I'm going to finish up that proof tomorrow. But that's it for today. Talk to you tomorrow. See you.